Hello, today we're going to be translating trigonometric functions. And so our translations will often appear as a plus or minus value to either the function itself on the outside, like this k, or a plus or minus h on the inside, like what we see here. So let's just go over some things. Whenever we see an h value, that is a value that's affecting the inside, that's going to be a horizontal shift. And whenever we see a k value, that's going to represent a vertical shift. Specifically, plus k will shift everything up k units. And minus k shifts everything down k units. Plus h shifts everything to the left k units. And minus h shifts everything to the right k units. So let's describe what's happening here. On this one, we see this plus 2, and it is not inside some parentheses. So since it's not inside some parentheses, like what you see down here, we say this is on the outside of the function. So this is going to be a k value. Oh, I'm sorry, I made a mistake. This should be shifting everything to the left h units, and to the right h units. My bad. And so, here we see this on the outside, so that's going to be a k value. And so since it's positive, it's going to go up 2 units. And then for this tangent, we see a minus 1. Again, there's no parentheses, so it means it's on the outside. It's going to go down 1 unit. These ones are both on the inside. And so sine of x plus pi over 2 means it's going to go to the left pi over 2 units. And cosine of x minus pi is going to go to the right pi units. For helping us graph this, we often look at something called the midline. When we shift a graph vertically, we will create a new horizontal axis. This axis is called the midline. Here, I'm going to draw it. So for the regular one, the midline is on the x-axis. And the midline for this one is going to be on the line y equals 4. So the equation for the midline is y equals k, where k is that shift from before. The midline is the reference line to which a graph oscillates. So here the midline is at 0, so it's oscillating around 0. Here the midline is at 4, so it's oscillating around 4. Let's take a look at a couple graphs. First, we can identify what the amplitude is. The amplitude that is at 3 over 2. The period is equal to 2 pi over the b value. In this case, the b value is 1. So that's just 2 pi. Another word for a horizontal shift is a phase shift. That's also included in your earlier notes. Horizontal shifts are also called phase shifts. Oh, so since there is no shift happening on the inside here, there is no phase shift. So then we can write down none. There is a vertical shift. It's going up 3 because we see that plus 3 on the outside, and there is so the new midline is y equals 3. So I'm going to draw some of these now. I'm going to start out by drawing my midline at y equals 3. That makes it pretty easy. And then I'm going to draw my sine function as I normally would. But instead of starting at the origin, now I'm going to start out where the midline is, where the midline crosses the y-axis. So I can start here. My period is 2 pi, so I know I'm going to repeat at 2 pi. I go halfway, and I go up by my amplitude. So here my amplitude is 3 over 2. So halfway between these, I'm going to be at 3 over 2 above the midline, and 3 over 2 below the midline. 3 over 2 below, this way, 3 over 2 above, and I get my nice sinusoidal graph. Let's do another one, and for this one we're going to use a different technique. We are going to graph the original graph basically with no horizontal translations, and then we'll look at what the new graph is. And so I'm going to graph some g of x here in orange. G of x is just equal to the tangent of x. So I can look at the period and the amplitude. So this is a tangent graph, so we know it has no amplitude. Its period is equal to pi over the b value, so pi over 1, which is pi. There is a phase shift. So a phase shift, it's moved to the left by pi over 2. Its vertical shift is, there is none. And so that means the midline is at y equals 0. I can still draw that midline, but it's on the x-axis. So there's not much different about that. So I'm going to graph g of x equals tangent of x just so we can see what the original looks like. We know that that's going to have asymptotes at every odd multiple of pi over 2. So 1 pi over 2, 3 pi over 2, negative 1 pi over 2, and negative 3 pi over 2. Then it would have crossed through the midline, gone up to its a value. The a value here is 1. Gone down, and it would have looked like this. Now I know that everything has been shifted to the left by pi over 2. So all these values, I go left by pi over 2. The asymptote, I go left by pi over 2. So the transformed graph, the actual graph, is going to look like this. And then you can keep going. Remember, the orange graph was just me showing what the original was, without any translations. Okay. Let's move on. We're going to do a few more. Feel free to skip around, look at whichever ones you feel like you'll have the most trouble with, because we're going to get a little bit more complicated here. First things first, the amplitude here is 4. The period is 2 pi over 2/3, which is just 3 pi. The phase shift, it goes to the right by pi. The vertical shift, it goes up 1. And the midline is y equals 1. Another technique for drawing these is just to redraw your axes. So I could say basically my new x-axis is at 1, and my new y-axis is at pi, because it goes to the right by pi. And then I can draw a standard 4 cosine 2/3 pi graph from here. And to help me out, I'm going to find what my step size is. And we know that that is just equal to pi over 2b. So pi over 2 times 2/3, which is going to be 3 pi over 4. So I know at every pi over 4, I'm going to have a new step. Let's draw our graph now. Cosine starts at the amplitude, so that's going to start at positive 4. Or it starts at the a value. If the a value was negative, it would have been down here. And then I go 3 pi over 4. Another 3 pi over 4 would have been down here. Going to the other direction, 3 pi over 4. And so you see that whole period of 3 pi there. We see that whole period. And then if I wanted to, I could have gone further. So let's graph this. Okay, and so that's another technique. For this next one, we'll use the same technique, and then we'll try mixing it up. Okay, so we can see that the period would equal pi over 2, because it's just pi over the b value. That's pi over 2. There is no amplitude because it's a tangent function. And then it's going to have a phase shift to the right, or to the left, by pi over 4. A vertical shift up, or down 3, down 3. And a midline at y equals negative 3. I could draw my midline. I can draw where my phase shift changes my y-axis, so it's going to be at pi over 4 now. And we might want to recall then on a tangent function, that the asymptotes are at odd multiples of pi over 2b. So in this case, it's going to be odd multiples of pi over 4. So that's going to be 1 pi over 4, 3 pi over 4, and then the negatives as well. And I mean these values from the y-axis. And so since our y-axis transformed, I now know they're going to be over here instead. So that's pi over 4. That's going to be 3 pi over 4 away from our transformation. 5 pi over 4, 7 pi over 4, negative 1 pi over 4. Oh, whoops, that's not negative 1 pi over 4. This is negative 1 pi over 4. Ignore this. Negative 2 pi over 4, negative 3 pi over 4, negative 5 pi over 4, negative 7 pi over 4, and negative 9 pi over 4 away from our transformation. Now we can draw our graph. Remember, it's going to go through that origin, or at least where our transformed origin is. And then we repeat. Because these are all periodic functions, they're all going to have this repetition to them. The big part about this is being able to recognize the correct graphs. Being able to see that this has this has the right asymptotes and has the right midline and all that. Let's do a few more. Let's do a couple of these based off the transformations. So here we see that without any vertical or horizontal transformations, I can see that this would be 3 sine 4x. So that means its period would be 2 pi over 4, which is pi over 2. Its amplitude is 3. Its phase shift, we can still look at these. Phase shift would be going to the right by pi over 2. Its vertical shift is down 2. And its midline would be at y equals negative 2. So to draw the original, I just need to do the 3 sine 4x, which is just looking at the amplitude of period. So we know sine starts at the origin. And then at pi over 2, it's going to finish the whole cycle, so halfway there. And then it has to go up and down 3. So halfway between those two is 3. So before we do any vertical and horizontal transformations, that's what like one period would look like. Okay, now let's draw our midline at y equals negative 2. And our phase shift, which is right by pi over 2. And so we just need to draw this same graph transformed. And you just keep going. What I'm doing right here is drawing all my places where they intersect the x-axis before I draw all my peaks And I know that my peaks are going to be pi over 2 away from each other. And my crests are also going to be pi over 2 away from each other. And so that makes it a bit easier to draw. If I just think about drawing all my points first. And then my peaks on this side. And so I can just draw my line now. It's very squiggly. You can also, and then, it's always nice to confirm your graph on a calculator. Okay, let's continue. I'm going to draw this graph using, again, the transformation technique where I draw the unphase shifted, untranslated one. So that'll just be cosine of 2x. We still want to think about its amplitude, which is 1, because there's no number in front. That number is 1. Its period, which is going to be equal to 2 pi over b, which is 2. So 2 pi over 2, which is pi. And then we have enough to graph the untransformed one. Let's just graph that now. So cosine we know starts at the amplitude, so that's going to be starting at 1. And then at pi, it's going to complete a cycle. Halfway between this is going to be down there. And then you can just repeat. Pi, just add pi to each point, subtract pi. It's nice to think that every one of these is pi over 4, so 4 blocks would be pi. That's what goes on in my head when I'm looking at this. 4 blocks away from here is pi. 4 spots away from there. 4 more. And then I can just fill in the remainder. And so this would be my untransformed graph. Now let's look at that phase shift. The phase shift means we're going to go to the left by pi, or by 3 pi over 4. And my vertical shift means we go up 4 with a midline at y equals 4. Remember, I'm getting these values from here. And so let's draw where my phase shift would put my new axis. So that's left. There. And then down, and then y equals 4, so up 4. And the graph is going to look the same. It's just now in a new position. So period still is pi, but now, and we can still do our blocks of 4 thing. 4 blocks. Same thing there on the bottom. It's just been moved. Every point has just been moved up 4, and to the left by pi over 3. And then you put your intermediate points. And so yeah, we see we get the same graph. One more and then we'll be done for the day. Let's look at this tangent one. And we can do this tangent one by transformation or just by reorganizing it. I don't necessarily like to look at tangents as transformations, just because it messes with my head a bit. So I just like to redraw the axis and pretend that I'm just drawing it originally. So I'm just going to skip to the period. which is going to be pi over 1/2. Ooh, that's nice. That's 2 pi, a nice big period. And then no amplitude. I like the bigger period because it means I have to draw fewer asymptotes. We go to the left by pi, and then up 1, which means our midline is at y equals 1. So our new axes are basically here at 1, and so left pi means negative pi. And I can just take, find where my asymptotes are at, because it's the odd multiples of pi over 2b, so that's 2 times 1/2. So that's odd multiples of pi over 1, which is just pi. So that's going to be at 1 pi, 3 pi, negative 1 pi, and so on. So 1 pi away from here would be here. 1 pi away from, or 3 pi away would be right here. And negative 1 pi would have been here. Remember, I'm just really counting blocks of 4 as pi. So now we can graph our function. I know halfway between those asymptotes, I'll have my points. And I can even look at this too to help me make a more accurate graph, because halfway between those there would be a point at 2 and a point at -2, point at 2, point at -2, but ultimately we need to follow our asymptotes. And so being able to recognize that is really crucial. If you want to, you can say like, oh, there's going to be a piece over there and a piece over here. And that's it. Thank you for watching. If you have any questions, feel free to ask me in person or to leave a comment on this video. So thanks for watching and have a great day.